identified as not being in the data set? Well, say it's a really large data set of diabetes patients. I might be able to predict pretty well that someone doesn't have diabetes by saying they're not in the data set. So I'll just say, if I don't know that you don't have diabetes, then I don't insure you. The same thing. So you may want to be able to say not only that I can't predict someone is in the database, but I can also not, I can't really predict that they aren't in the database either. The idea here is that every individual is sufficiently hidden within T star that we can release T star. And the risk of identifying the individual is small. So what's sufficient? If I were to tell you that I'm going to publish this data set and there is a, say I have diabetes, and there is a 5% chance, I'm in this data set, but from looking at the data set, you'd say there's a 5% chance that I am an individual in that data set. Is that, would you think that that's a privacy problem? And that seems, this data set maybe of 1,000 people, and to say that, well, there's a 5% chance that I'm actually one of those people. How many people would view that as probably a privacy violation? How many people think it wouldn't be? Most of you seem to be very unsure about this. Well, let's start talking about this, not in terms of just the disclosure, but let's actually talk about the harm. So, the harm could be quantified. What is the harm? Well, I'm denied insurance. What's the cost associated with that? Well, diabetes patient, there's a cost of around $10,000 a year. So we can apply a dollar figure to what is the cost of being discovered in the database. The disclosure can be quantified. I can predict how likely I am to be discovered in that. But is that really what the adversary is learning? Well, the interesting thing about this is that if I were to ask you to say right now, knowing nothing else, what is the likelihood that I have diabetes? What would you say? How many would say, 1 in 1,000? 1 in 10,000? 1 in 100? One person with 1 in 100. 1 in 10. One person who knows something about diabetes. 7% of the population has diabetes. Once you adjust of kind of the normal adult population. So even if you know nothing, somebody can make is going to guess that with 7% probability. So if I disclose this database and say, well, you can take this individual and I know that Chris has a 5% shot of being in this database. How much is that really changing your estimate of the likelihood that I have diabetes? Not near as much as it would seem at first glance. It does help you some, but it doesn't all of a sudden go from 0 risk to 5%. You already thought I had a 7% chance. Prior knowledge is key in understanding the risk of harm. So given this, it actually turns out that we can calculate the expected, we can set delta max to 0.05, 5% probability that I've been identified, and the kind of expected cost working this out works out to be less than 100. That's very close to noise in these things, much less than the commissions on insurance policies. So it turns out that if we start thinking about what is the potential for harm and what is the prior knowledge, it really can affect things. Now, the other thing about this little study here is if we take this notion of delta presence, just identifying someone in the database, and use something like k-anonymity as a measure, it turns out that it's a very wrong solution for this problem. Saying that I'm going to have to anonymize in a way that groups people into groups of k in order to meet that 5% disclosure standard doesn't really do a good job. It fails in two ways. One is you can't set a threshold of k above which you're going to pass that standard, below which you won't. Actually, turns out you can find a k-anonymization that meets that standard. Then you can increase k and end up with a k-anonymization that doesn't meet that standard for this risk of disclosure. The second thing is, even when you do, and this is comparing a straightforward technique on the left side, the barred histogram, a fairly simple technique which tries to directly optimize towards this delta presence measure, with one of the better k-anonymity algorithms that's out there. And the vertical line, or the vertical height, corresponds to the amount of distortion in the database. Loss metric is, for those of you who've read the k-anonymity literature. It corresponds to how much you have to change the data, how much information you have removed from the data in order to anonymize it. And we have to remove a lot more information when k-anonymizing the data. In fact, effectively eliminating all information from the data for many of these values in order to get a data set that meets this property of limiting the ability to find any individual in that data set. So that's an example of some of the difficulties here with these metrics, is they don't always agree with the problems that we have. So where do we go on this? And I'd like to see some discussion here. I think there's a couple things we really need to be able to start to quantify and talk about. One is the risk. What is the knowledge that an adversary could gain from the data that is being disclosed, the knowledge that is being disclosed? What does an adversary really stand to learn from this? And the second, what is the potential for harm from this knowledge? Now, in that one case, we can come up with a fairly straightforward economic way of measuring it. In other cases, this is more difficult, but there have been some studies done on how people measure their own risks, their own harms, how they understand these. If you start to be able to pull these in so that you can work with it, then you can give people a better view of the risk. When you walk into how many of you have been into a hospital or medical clinic or whatever in the last 2 years? Most of you? How many of you have signed paperwork that talks about how they will protect and what they may do with your data? Yeah. How many of you really feel that that in doing so you're allowing them to disclose data, that you're giving them the right to disclose data in ways that you might not really want? Yeah. How many of you didn't read those closely? Okay, that covers the rest of you. Part of the problem is we're not given good information on what the potential risk is, what the potential harm is. And I think if we can better quantify that, better understand that, so that when you walked in, you would be told, we may use your data in studies, but in doing so, we will anonymize it such that